Hello, everyone. Thank you for joining us for the fourth episode of this workshop series. Today's episode is Automating Changes and Preventative Maintenance in an Enterprise Cloud Environment. My name is Eric Weber. I am a Senior Specialist Solutions Architect for Cloud Management Services here at AWS. And just to go over a quick agenda of what we'll be going through today. First, we are going to be going into the workshop directly just to start off with some initial setup. Following that, we're going to go through an overview of Patch Manager and some of the core concepts around patch baselines and the operations and scheduling mechanisms. And then we'll be talking about Change Manager, where we'll also be going through an overview and talking about more specifically change requests and change templates. And then we'll go into the hands-on workshop after that. So to get started with the initial workshop setup, we're going to go to the GitHub repository. So starting at the GitHub repository for episode 4, step 0, or the overview page, we will scroll through here where you can see the table of contents, which will describe a little bit of the summary of what we'll be doing today, as well as our learning objectives. So to get started with that initial setup, we're going to go into the next section. And in here, we are just going to go through this initial prerequisite portion for standing up some initial resources that we'll be using during the workshop itself. So to deploy these resources quickly, we're going to be using a CloudFormation template. So what you're going to do is open up the CloudFormation template, and we're going to select raw. And then in here, you will want to copy the entire contents and open up a notepad. Where you will then paste the contents and want to save the file locally. And for the purpose of this, I'll be naming it the SSM Workshop Resources episode 4.yaml. So now that we have our CloudFormation template stored locally, we are then going to go into the management console and go over to CloudFormation to deploy the stack. The CloudFormation template is going to create, like I said, some sample resources that we'll be interacting with in the later portion of the workshop. We're going to be standing up a VPC and subnet resources so that our Amazon Linux EC2 instances can communicate with these Systems Manager endpoints. It'll also be standing up an EC2 Iem instance profile role, so those instances have permissions to communicate with these Systems Manager endpoints. There will be 2 S3 buckets that are created. One will be for the command output logs, which will be for our patching operations. And then there will also be an S3 bucket created, which will be used for a resource data sync, which we'll talk about more later on. 2 other roles will also be created in order to enable multi-account and multi-region functionality for Systems Manager automation. And then one final role will be created to enable Systems Manager Explorer, which is in turn going to be enabled using a State Manager Association, which will then enable our Explorer console for review when we go through the patching portion. So to create the CloudFormation stack, like I mentioned, we're going to go to the CloudFormation console. We're going to choose Create Stack and upload that local template file that we created. So after we click Next, we're going to go ahead and fill in our stack name. And you'll see here one of the parameters that is being listed for the latest Amazon Linux AMI ID. This is actually a parameter store value. So this is using our public parameters in Systems Manager parameter store so that we can ensure that we are always using the latest available Amazon Linux 2 AMI without having to actually be aware of what the underlying AMI ID is. We can just reference the public parameter instead. So we'll just go ahead and hit Next, and then we'll hit Next again, and then we'll scroll to the bottom and go ahead and check this off and hit Create Stack. So this is then going to begin deploying those resources that we were talking about over in the GitHub repository. And since this will take a couple of minutes, we'll now flip back to the presentation. So first, we're just going to talk about Patch Manager. So you can use Patch Manager to apply patches for both operating systems being Windows and Linux. You can patch both EC2 instances as well as hybrid managed instances. And within Patch Manager, we're going to be defining the criteria and type of rules that we want to install and or mark as missing when we perform patch scans or install operations. As far as our scheduling mechanisms go, there are a couple different ways that we can go about scheduling patching operations, which we'll talk about later on. And by using Patch Manager, it helps you shorten the time to install zero-day vulnerability patches using a couple different mechanisms. Again, we'll mention in just a moment. And once you perform these patching operations, then you start getting these dashboards that you can then view to get a quick at-a-glance view of your overall patching state. So over on the right-hand side, we can see an example patching dashboard within Patch Manager, where we have 6 overall total managed instances. One of them is missing a particular package. And then we can always see what are our recent patch operations, which resources did we target, what are some of our common reoccurring patches. And if there are instances that are checking into Systems Manager but have never been patched, either that is a scan operation or an install operation, those will also be highlighted in that compliance reporting age widget. And then if we want to expand this across our entire AWS organization, we can then aggregate the data using Systems Manager Explorer to have a more holistic view across the entire environment. But to go into a little bit more detail around Patch Manager, like I mentioned, Patch Manager supports both EC2 instances and hybrid managed instances, which can be servers or VMs in an on-premise environment. And Patch Manager supports the major Linux operating systems such as Amazon Linux, Amazon Linux 2, CentOS, Debian, Oracle, Red Hat, SUSE, and Ubuntu. And then Patch Manager also supports Mac OS on EC2, as well as Windows servers, both in EC2 and hybrid. And within Patch Manager, we're going to be creating what we call patch baselines, which are, again, going to define the criteria for the types of updates to scan or install. And then those updates that are then approved by your baseline criteria and are missing will then be reported to those patch compliance locations that we were just talking about, where you can then quickly identify which of your overall managed instances are missing updates, as well as what is the overall severity and what specific updates are being marked as missing. This information, like I mentioned, can then be aggregated into Systems Manager Explorer across your overall organization. And then Patch Manager also has native integrations with AWS Config, which can be leveraged for historical retention of your patch status and compliance. So you can always go back and review what was your current or what was your previous patching state, let's say 30 days back. It also has integrations with AWS Security Hub to aggregate findings across your organization. You can also leverage Amazon Event Bridge to issue actions following specific state changes or compliance changes. And then you can also bring in the patch compliance data into Amazon Athena and or Amazon QuickSight for alternative reporting methods as well. To go into the patch baselines a little bit further, again, they are used to define the criteria for the type of updates that you want to scan or install for during patching operations. Patch baselines are operating system specific, but you can always create multiple baselines for the same operating system type. And the reason that you may want to is to create different patch baselines for subsets of resources that require different sets of updates compared to others. For example, you may have different patching criteria for database servers or Active Directory domain controllers compared to standard web application servers, which may be a little bit more lenient as far as the updates that are being applied. So you may want to create specific baselines for each of those workloads. And then within your baselines, you can have multiple rules which each have their own compliance reporting level that can be specified, which allows you to, again, identify quickly at a glance the patching state of your environment. And within each of these rules, we're going to be defining the product, the classification, the severity of the updates that we want to scan or install. You can also include auto approval mechanisms as far as either a specific number of days that a patch needs to be released prior until it is marked as missing, or you can specify a specific date or a cutoff date for when patches need to be released prior to in order to be considered for installation. For Windows workloads, patch baselines support both operating system updates and Microsoft application updates, such as Exchange Server, Microsoft Office, Silverlight, Microsoft SQL Server, and more. For Linux workloads, you can choose to install non-security updates in addition to security updates. And additionally, for Linux, you can specify an alternative repo to be used during the patching operations. The alternative repo will then override the repo configurations within the operating system. One thing to keep in mind when using Patch Manager is that your instances must have access to a repo in order to scan or install updates. These can be remote repositories, such as Microsoft's Update Catalog in the case of Windows, or in the case of Red Hat, it could be the Red Hat Update Infrastructure, or RUI. Or your managed instances can leverage hosted repositories within your environment, such as Windows Server Update Services, or WSUS for the case of Windows, or in the case of Red Hat, an example being a Red Hat satellite server. Lastly, within your baseline rules, you can also specify any explicit exceptions that need to be made. These can be explicitly approved patches or explicitly rejected patches. Rejected patches can either be flat out blocked and never installed, or you can specify that they are only to be installed as a dependency for an approved package. After you have defined the criteria for the type of updates that you want to scan for or install using patch baselines, you are then ready to begin performing the actual patching operation. Patching operations can either be invoked on an ad hoc basis or occur on a scheduled basis. When performing patching operations, you will primarily leverage two AWS provided documents, AWS Run Patch Baseline or a recently released document called AWS Run Patch Baseline with hooks. Within the document AWS Run Patch Baseline, you can specify an install override list, which, as the name suggests, allows you to provide a JSON or YAML formatted specific list of packages that you want to install, which will override your baseline criteria. This helps reduce the installation time of zero-day vulnerabilities by allowing this very granular approach to install a small set of updates without having to modify your overall patch baseline rule criteria. When you choose to perform an install operation, you have a few options around the reboot behavior. You can specify to reboot the managed instance if needed, meaning if approved missing updates are installed, then Patch Manager will enforce a final reboot. Or you can specify that patches should only be installed without rebooting the managed instance. You can also schedule a later point in time to reboot the instances following patch installation. You can then target your managed instances for patch scans or install operations using resource tags, resource groups, specific resource IDs, or just target all managed instances that are checking in with Systems Manager. And then after the patching operation completes, whether it is a scan or an install, you can specify to have the command output logs to be stored either in Amazon S3 buckets or Amazon CloudWatch logs. And like I mentioned, a recently released feature that was added previously this year is called Lifecycle Hooks, which leverages the document AWS Run Patch Baseline with hooks. This document allows you to run commands and scripts using command documents, which can be called at various points during the patching operation. For example, you can run a set of commands before patching installation to gracefully stop applications and services on your managed instances. You can then run a different set of commands to update applications immediately after patching. And lastly, if you choose to reboot your managed instances, you can then run a set of commands after the instance comes back up from the reboot to start your applications and verify their application health. Patching operations can be scheduled in multiple different ways, which each have their own benefits. Systems Manager best practices recommend that you perform daily patch scans using State Manager associations. In order to quickly configure these associations across your entire environment, you can use Systems Manager Quick Setup, which was talked about in episode 3. State Manager associations can also be used for scheduling the installation of patches using a cron array-based expression. However, one benefit of using maintenance windows are that they provide a scheduled offset parameter value. For example, on the right-hand side in the screenshot, you can see the maintenance window is configured with a cron expression to run at 2 a.m. UTC on the second Tuesday of the month. And there is also a scheduled offset value of 4 days. This means that the maintenance window will actually run on the Saturday following the second Tuesday of the month. And this can be very helpful in the case of Windows workloads where you need to ensure that patches are installed following Microsoft's Patch Tuesday, which takes place on the second Tuesday of the month. You can also use Amazon CloudWatch to kick off actions or other workloads based off of events that take place within your accounts. And you can also leverage Systems Manager automation to perform patching operations across multiple accounts in multiple regions. So now to talk about Systems Manager automation a little bit further, which has also been spoken about in episode 3 of this workshop series, so we'll be fairly brief here. But just as a recap, again, automation is used to eliminate manual effort for common tasks within your environment by using custom workflows or predefined workflows that are maintained by AWS. When you are kicking off automation runbooks, you can receive notifications about the task and their progress using EventBridge and SNS notifications. And then you can also monitor it within just the standard AWS Systems Manager console as well. You can always call automation runbooks either manually using the console itself or programmatically using our CLIs and SDKs. Within our runbooks, we can create those dynamic workflows that will leverage conditional-based branching. So in the case of that run patch baseline with hooks operation, should that overall process fail, we can then leverage an automation runbook to then perform additional steps as needed, such as rolling back to a previous EBS snapshot or notifying the appropriate individuals to go and review. And then in the context of patching operations, we will also be using Systems Manager automation to perform multi-account and multi-region patching, which we'll take a look at within the workshop. Before we go into the workshop, next we're just going to talk about Change Manager. So Change Manager is a way to essentially aggregate changes that are going to be taking place within your AWS environment. So by using Change Manager, change requests, and change templates, you can maintain that DevOps agility with these pre-approved templates that are going to define the actions that are going to take place as part of these overall change requests. By using Change Manager, you can help reduce business impact by restricting changes so that they only take place outside of important events through the integration with Change Calendar. In Systems Manager Change Calendar, you can define when these events are occurring, which Change Manager will then query first to ensure that changes are only taking place during the appropriate time periods, or if appropriate, you can specify emergency changes as well to override those Change Calendar events. You can also configure best practices within Change Manager to provide guardrails, which means that we can include CloudWatch alarms, which can automate rollbacks should anything be triggered, should any alarms be triggered during the overall change request operation. You can also include template reviewers to ensure that only the appropriate actions are being taken place. And then you can manage changes from a single account using delegated administration across your overall AWS organization. So you can submit changes into a single account, and then those operations will then be performed within those target accounts that you specify. You can simplify user onboarding using either existing AWS IAM users and groups, or you can integrate with AWS SSO as well. To talk about a change template further, a change template is a collection of configuration settings within Change Manager that define things such as required approvals, available runbooks, and notification options for change requests. You can require that the change templates created by users within your organization or account go through an approval process before they can be used as part of change requests. And then Change Manager supports 2 different types of change templates. For an approved change request that is based on an emergency change template, the requested change can be made even if there are blocking events in Change Calendar. And then for an approved change request that is based on a standard change template, the requested change cannot be made if there are blocking events in Change Calendar unless additional approvals are received from a delegated change freeze event approver. And we'll be taking a look at both of these options once we go into the workshop later on. To talk about a change request a little bit further, a change request in Change Manager allows you to run automation runbooks that updates 1 or more resources in your AWS or on-premise environment. And a change request is created using those change templates. When you create a change request, 1 or more approvers within your organization or account must review and approve the request. Without the required approvals, the runbook workflow, which applies the changes for the request, is not permitted to actually run. You also have flexible scheduling options for your change requests. Change requests can either occur immediately and start after the required approvals have been met, or you can specify a later point in time for the changes to occur. If you do specify a later point in time, the change request approvals must be met or the change will not be initiated. In Systems Manager, change requests are stored as a type of ops item within Systems Manager Ops Center. And this means that you can create change requests using Systems Manager APIs, such as start change request execution. And when we are using these APIs, the change request must still be approved, and there must not be any blocking events in your change calendar to prevent the workflow from running. When approvals have been received and the calendar is not blocked, or permissions have been given to bypass the blocking calendar events, the start change request execution API action is then able to complete. So now that we have a bit of an overview of the various capabilities that we're going to be talking about today and working with in the hands-on portion, we can then go back to the GitHub repo. All right, so back in the GitHub repo, now we're going to make sure that our CloudFormation stack completed successfully. So we can see that the stack is now in a create complete status, which means that we can then go ahead and begin with the remainder of the workshop. So to get started with the remainder of the workshop, first we are going to create a patch baseline within Patch Manager. So to do that, we're going to go to the Systems Manager console. Next, we are going to go to Patch Manager. And we're going to select View Predefined Patch Baselines. So in here, we can see that AWS does provide some default patch baselines for each of those different operating systems. But for now, we're going to create a custom patch baseline. In here, we are going to fill out our name. We are going to specify the description. And then we're going to change this to Amazon Linux 2. Because the EC2 instances that we launched using the CloudFormation stack are Amazon Linux 2 instances. Next, we'll scroll through here and we'll take a look at the approval rules and build these out. For product, we're going to leave the default value of all. For classification, we're going to select security and bug fix. And then for severity, we're also going to select all. We are going to leave these auto approval mechanisms as the default of 0 days for now. And then for the compliance reporting, we are just going to specify critical here. We'll then add another rule. And then for this rule, we're just going to select the checkbox of include non-security related updates. And then we'll just change the compliance reporting to medium instead. So now when we perform a scan operation in a moment, if there are updates that are missing based off of this first rule, it'll have a compliance value of critical. And then if there are updates, if there are those non-security related updates that are marked as missing, it'll have a compliance reporting value of medium. So then we'll scroll down to the patch exceptions list. And in the approved exceptions, we'll enter kernel with an asterisk, so that we can ensure that any kernel-related updates are also installed as part of this patch baseline. And then we'll select that our approved patches do include non-security related updates. And like I mentioned previously, you can optionally choose to include alternative patch repositories for Linux operating systems. If we want to do that, then we would just include this option where we would include our repo config. But for now, we'll just go ahead and hit create patch baseline. Now that our patch baseline is created, we'll just go ahead and hit view details up here, where we can then see the criteria that we defined previously. To map this particular baseline with some of our EC2 instances that we created using CloudFormation, we'll go up to Actions and select Modify Patch Groups. So in here, we're going to specify the value of app. And this patch group value can be any value that you want to specify, because in a moment, we're going to be attaching resource tags to our EC2 instances. So patch groups can correspond to specific environments within your environment. They can correspond to specific workloads, essentially any value that makes sense within your environment. Next, we're going to go over to the EC2 console to add those resource tags. On the left-hand side, we're going to select tags, and then we'll select manage tags. So for these first two instances, we're going to select those. And then in here, we're going to specify patch group, and then that same value that we just added. Something to keep in mind is that when we are creating these patch group key value pairs, patch group is case sensitive. So you must include a space as well as capitalization for each word, but the value can be any value that you specify. Again, you will just want to ensure that it corresponds with the value that we added over here within our baseline. So we'll select add tag. For our other two instances, we are also going to add a patch group. In this case, we'll add web. So just to go to the instances console, just to confirm that our tags have been added, we'll pull up one of our instances, and we can see here that we now have that patch group with app, as well as for our web instances, we have patch group with web added. So now that we've added those two options, we're going to go back to Patch Manager. And we can see within our patch baseline here that we added that patch group of app value. And what this means is that when we perform a scan operation for our EC2 instances, the determination of which baseline to use is performed within the operating system of each managed instance that we end up targeting. So in the case of this app1 instance, the SSM agent within the operating system will first evaluate which patch group it has. So in this case, patch group app. It'll then query Patch Manager for a corresponding baseline. In this case, this particular baseline that we previously created. And then it'll go ahead and continue with the operation, leveraging these rules that we defined. In the case of our web instances, which have patch group of web, the SSM agent is going to take this patch group web results, and it'll go and query Patch Manager for a corresponding baseline. But if we go to the patch group tab, we'll see there is not a corresponding web patch group. And what this means is that those two instances will instead leverage the baseline that is specified as the default for the particular operating system. So in the case of Amazon Linux 2, the baseline is currently the default baseline provided by AWS. If I happen to change the custom baseline that we created and specified this baseline as the default, it would instead leverage my custom baseline. So now that we defined our patch baseline criteria for the type of updates we want to scan or install, we're going to perform a scan operation. And just before we perform that operations, we're going to go to the dashboard tab. And like I mentioned during the presentation portion, over in this compliance reporting age widget, we can see that our managed instances that we have checking in have never reported their current patching state. That's just because, again, we never performed a patching operation against them. So now we're going to perform a patch scan, and we're just going to perform that using the patch now operation. So in here, we're going to leave the default value of scan, and then we're also going to leave the default value of patch all instances. For our patching log storage, we're going to select the dropdown, and then we're going to change this to the SSM command logs bucket, which was created by that CloudFormation template. And then we'll also leave the Lifecycle Hooks option disabled, and we'll go ahead and select Patch Now. So when we kick off this operation, it's going to perform a scan operation on our 4 managed Amazon Linux 2 instances. This is really going to create a state manager association on the back end, which is then in turn going to call that run command document, AWS run patch baseline. So this should take just a moment just to perform a scan, and looks like it is now completed. So if we want to take a look at the state manager association, we can open up this link. where we can see, again, it's going to be using the AWS Run Patch Baseline document. This is just a single operation, so there is no schedule. If we go over to our resources, we can see that it was applied against those 4 Amazon Linux instances. And then if we go either to the execution history, we can open this up and see our managed instances. Or if we go back to the previous page, we can also click the execution ID here in order to get the resulting command logs. So if we click on the output option here, we'll then be brought over to the run command console for a specific managed instance, where we could then expand our patch Linux step name and review the resulting output. Something to keep in mind is that the System Standard console displays a maximum of 4,800 or 48,000 characters. So in order to view the entire log output, because our results are going to be truncated, we included those output options for S3. So we can always open up our S3 buckets here. Where we can then open up and see the SCD out file. Now, typically, these will only be required for review when we are troubleshooting as far as why a particular patching operation failed. When we're talking about day-to-day operation and normal usage, we most likely do not need to review these log files. Rather, instead, now that our patching operation is completed, we can go back to Patch Manager, and we can go to the Dashboard tab, where we can see that our 4 managed instances have now been patched, and they've reported within the past 7 days. And they are also all compliant with our patch baseline rules that we defined. So in here, we can see our recent patch operation that was performed, our scan operation, which was just performed against all of our instances, and it was successful. And then now that we performed this scan operation, so because within that CloudFormation template, we specified that we are using the latest available Amazon Linux 2 AMI, our instances are not actually missing any updates. But just for the purposes of demonstration, we're going to go through the install operation anyway. So this is what it would look like if our instances were missing updates. So we're going to go back to Patch Now and select that scan and install. And then in here, we have those reboot options, meaning when are the reboots actually performed after patches are installed. For now, we're just going to leave the default of reboot if needed. And again, we'll leave it as patch all instances. And we'll specify or leave the default again as our command logs bucket. And we'll leave the lifecycle hooks disabled again. And we'll just hit patch now. So normally, if there were updates that were marked as missing based off of our patch baseline criteria, those updates would then be installed at this point. And then because there were missing updates installed and we chose reboot if needed, the corresponding managed instances would also be rebooted after the installation process. All right, so looks like it's going through our instances now. We can see one has already been successfully completed and there are still 3 pending. As we know that there are no missing updates on these instances, we're just going to go ahead back to the Patch Manager console rather than waiting for this to complete. So let's say that either there were missing patches for specific managed instances, or now that all of our instances are brought up to the appropriate patching state, we want to go ahead and report on that information. So if we want to export these results, we can go over to the Reporting tab. And if we want to export results for a specific instance, we would select it from here. However, in the case of what we are looking to perform right now, we're just going to choose to not select a particular result, and we're just going to specify export to S3. So in here, we're going to fill out our report name, which is going to be SSM Workshop. And when we are setting up this export to S3 operation, we can either just perform it on a single basis or an on-demand basis, or we could alternatively specify that we want to run this export job on a schedule using a cron array-based expression. Again, for now, we're just going to select the on-demand operation, and we'll be targeting our command logs bucket. You can optionally choose to include an SNS topic so that notifications are published once the report has been successfully generated, but we'll just go ahead and skip that and just hit submit. So now our patch export process is going to begin, and it looks like it already has succeeded, and it's starting to generate the report and download it to the S3 bucket. So this should just take just a moment just for this to go ahead and proceed before we can take a look at the resulting CSV file over in the S3 bucket. All right, so our report has now been generated and downloaded to the bucket. So before we do that, what this is actually performing is a automation runbook using the document export patch report to S3. So if we were to click on this generation ID, we would be brought over to the automation console where we could see the resulting workflow that was performed. So in here, we could always expand the various input parameters that were performed, as well as what was the actual step input and outputs. If we go back to that patch reporting tab, we can always just then select view report to see the resulting CSV file in our S3 bucket. So in here, we can then go to Object Actions and open the CSV file, or we could download the CSV file to our machine locally. And once you have the CSV file, you can then share it across your environment, or you could then import it into services like Amazon Athena and QuickSight for some more visualization and dashboard or query-based functionality. But for now, that concludes the first section of the workshop. So we're going to scroll through here down to the bottom of the page, and we're going to go ahead with the next section. So in the previous section, we were performing these patch scan and patch install operations just on an ad hoc or an on-demand basis. So this particular section of the workshop is going to focus on the scheduling aspects and automating some of these patching operations. We're going to go back to our Systems Manager console. And when we kicked off that CloudFormation template, like I mentioned before, it created a couple different IAM roles. So we're going to open up the IAM console. So in the IAM console, we're then going to go over to the Roles tab. And then if we filter by the word automation, we can see those two IAM roles that were created by the CloudFormation template. So these two IAM roles are used as part of the multi-account and multi-region functionality of Systems Manager automation. Within the central account, where you're scheduling the operation, you would create the automation administration role. And then within each target account, you would then create the automation execution role, which can then be assumed by this automation administration role and actually performs the workflow defined within each of those target accounts and or target regions. So if we go back to the Systems Manager console, we're also going to go over to the Documents section. All right, so over in the Documents console, in order to get the name of the document that we want to look up, we're going to open up the CloudFormation stack just to review it and go to the resources. And then in here, we can see that we have our SSM document. So it looks like the name of our document is listed here. So in our Documents console, we're going to go to the Owned by Me tab. We're just going to filter. And then we're going to open up our document. So in here, we can see our automation document that is going to kick off a single step, which in this place, it's going to initiate a run command document for AWS Run Patch Baseline, which we talked about earlier, against our target specified instances. And some things to note within the parameter inputs here is first that we have that command log being exported out to our S3 bucket. Additionally, we have our S3 key prefix being built out dynamically so that when the operation is invoked, if we were to specify multiple accounts and regions, we're going to be leveraging the Systems Manager automation system variables, which will build out these parameters and resolve them within each target account and target region during the overall operation, so that our command logs for the patching operation are then segmented by the account ID, the region where it is initiated in, and then the execution ID specific to that workflow. And then our target section, we're going to be specifying using resource groups in this particular case, but this can always be modified to specify specific resource IDs or even resource tags. So to kick off this operation in a multi-account fashion, now that we've taken a look at the automation rules, as well as this resulting document, we are going to create a multi-account, multi-region state manager association. And to do that, we're going to be using the AWS Cloud Shell service. So Cloud Shell, for those that are not familiar with it, is a way just to run commands quickly using the management console without having to necessarily download and install the AWS CLI locally. So it's going to set up an environment for us where we can then run the appropriate CLI commands to create our multi-account, multi-region state manager association. While this is starting up an environment, let's go back to the GitHub repository where we will skip to that section. And we're going to open up a configuration JSON for our association. So similar to the CloudFormation template, we're going to open up our association JSON and select raw. We're going to copy all of this information again. And we'll start a new Notepad instance. Paste in our details. And within this association configuration, we need to replace a couple different pieces of information, such as the document name that we want to run. So I'll take my document name here, copy that, go to my document and replace that. We'll also need to replace 2 instances of our account ID. So to get the account ID quickly from the management console, you can just open up this section here and copy your account ID. And here we'll then replace that value, as well as down here within our target locations, we're also going to specify our account ID. Now, in the case of this workshop, we are just targeting the same account and same region. But if we wanted to target multiple accounts and or multiple AWS organization units or OUIDs, this is where we'd be defining that criteria. So for example, if I had another account that I wanted to specify in here, I would be including that as a comment separated list, or I could also just include OUIDs as well. For now, I'll just include the same account and same region. This is where we would also be specifying if we wanted to target other regions. In this case, we're creating a state manager association, which is just going to perform a scan operation against our resource group of managed instances. The CloudFormation template also created a resource group called managed instances, which is based off of the criteria of the resource tag of our managed instances. So it's going to perform the scan operation at 9:30 UTC. And the other value that we're also specifying is apply only a cron interval, meaning that it'll wait for this cron expression to be met and then kick off the scan operation. And we're just going to be applying a compliance severity of medium. So we're going to save this configuration file locally. We'll be calling it association configuration.json. And now we'll go back to our Cloud Shell tab, which has set up our environment. And in here, we are going to then upload our file. Hit upload. And what we can see on the right-hand side is that our file is now available locally within our Cloud Shell environment using the path home/cloudshell-user. So now we are going to create our state manager association. So if we go back to our GitHub instructions, we can see the commands that we need to execute. We'll go ahead and copy and paste that in to create our state manager association. So it's going to return some results for us. We'll see in the overview section here that the status is pending, again, because we specified to only apply it at the cron interval. And then the detailed status will be creating, but that'll change in just a moment. So if we want to perform another describe operation to check the status of our association, we can then run the list associations operation. And then specifically, we're going to be filtering for our association above, which is going to be named SSM Workshop Multi-Account Patch. Go ahead and list out those associations for the one that we just created. So in here, we can see that it is in that pending state, again, because we specified that it should not run until that cron interval. So if we go back to the Systems Manager console and we go over to State Manager, we can see that our association for the multi-account has been created and it's in that pending state. So since it's going to wait for that specified cron expression and we want to go ahead and kick it off right now, we're just going to go ahead and hit Apply Association. So this is going to kick off our association right away. And we can open it back up and go over to the execution history, where we can now see that it is in progress. So if we open this up and select output, we'll then be brought over to the automation console, where we can see it began the operation and it's targeting the same account and same region that we specified within our configuration JSON file. So if we open this up, we can then see the execution ID that took place within our account. And it looks like it has changed to the successful status at this point. So if we go up, we can see that this particular region pair and account was successful. And if we go back to our automation console and we select Show Child Automations, we can see that our underlying execution was successful. And if we were to also go to the Run Command console, because again, it was performing a run patch baseline operation, we could go to the command history and see that it was also successful here. So now that our operation has been initiated, and again, we still have that scan as well as those install operation results. If we want to aggregate that data from multiple accounts in multiple regions, what we would want to use are resource data syncs within Systems Manager. These were also created as part of the CloudFormation template. So let's go to the Fleet Manager console just to take a look at the resource data sync. And then we're going to take a look at the data that was populated using the resource data sync. So if we select account management here, we can then go to resource data syncs. And then in here is the resource data sync that was created as part of the CloudFormation template. So if we open this up, we can see which resource, which S3 bucket was specified as part of the creation, as well as where this information should then be synchronized with. So if we go to S3 now, we can open up our resource sync bucket, and we can go into the inventory prefix, and we can see various information about our managed instances. So the resource data sync is going to take data that was collected from the inventory capability of Systems Manager, the patching results, as well as the corresponding compliance data, and synchronize it with the S3 bucket that we specified. So this can be a single centralized S3 bucket. And when we are working with multiple accounts and multiple regions, we just need to ensure that our bucket policy permissions are put in place to allow those other accounts access. And those can either be defined as specific account IDs, or in the case of AWS organizations, we can also specify an OUID instead. So if we were to drill down into one of these data types, in the case of Patch Manager, we can look into the compliance item. We'll see that it is segmented by the account ID, followed by the region. And then if we go all the way down, it'll be the individual managed instances just as JSON objects, which you could then always open up and review individually. But for the case of this workshop, we will just go back to the Systems Manager console. So if we wanted to review this information from a multi-account perspective, then we would want to use the Systems Manager Capability Explorer. So in Explorer, we can aggregate information across our AWS organization using a resource data sync. So in here, we would be creating a resource data sync. In my case, my account is not part of an AWS organization, but if it were, then I would be able to select one of these two other options, where I could say that I want to include all accounts within my overall AWS organization, or I could select individual organization units or OUs within my organization to display information from. And then just choosing which regions you want to collect data from as well. So once you create that resource data sync, it'll start collecting information from those other accounts and regions. And then we can scroll through here and see how many of our instances are not compliant with regards to patching. In this case, again, because our instances already are patched and up to date, we'll see that there are no non-compliant resources. So in a real-world environment, like I mentioned, we would be creating these resource data syncs, which will then collect information from our multiple accounts and regions, and then we can view that information within Explorer. So if we go down here to the bottom page, or the bottom section of the GitHub repo, if we were to have multiple regions as well as multiple member accounts within our org, we can essentially aggregate all of our patching data into the single dashboard console using Explorer. And then just to provide a recap, again, what we did in this section is that we took a look at the IAM roles for multi-account automation, as well as the custom automation runbook, which was initiated using a state manager association performed on a cron-based expression. The automation runbook called that command document run patch baseline, which then performed the scan operation. And then we took a look at Explorer to aggregate the data, as well as those resource data syncs to view the JSON objects. And then if you want to go further with the centralization of multi-account, multi-region, we do have a sample repository or a sample reference architecture, which can be reviewed in the AWS Management and Governance Samples repo, and then under Systems Manager, and then Centralized Patch Management. So in here, we have a very in-depth sample reference architecture that talks about scheduling multiple multi-account and multi-region patching operations. In this case, it's going to be using CloudWatch events as the scheduling mechanism. So outside of the workshop, feel free to go through here if you would like to learn more about some of these centralization efforts. Next, we're going to go to Change Manager. So in here, we're going to work with Systems Manager Change Manager. We're going to set it up. We're going to create a change template. We're going to approve the template, create a request, approve the request, and then review those results. So the first step is that we're going to create an Iem User that will be our change template and change request approver. So back in our management console, we're going to go over to the Iem console. We'll select users, and we'll select add user. So in here, we're going to specify the name approval user, and then we're going to specify management console access, and we're going to specify a password here. We'll deselect this option since we don't need to reset it. So we'll just go ahead and hit next permissions, and we're going to select attach existing policies directly. And then in here, we're going to select two different policies. The first one being SSM full access. And the second one is going to be CloudFormation read-only access. Go ahead and hit next tags, next review, and then we'll create that user. Then we'll go ahead and hit close here. And we're going to create one other service role for Change Manager specifically. So we'll go to the roles section of the console. We're going to hit create role. In here, we're going to go down to the section for selecting a base level use cases, and we'll select Systems Manager from the list. And then down here, we're going to select the first option of Systems Manager, and then we'll select next permissions. In here, we're going to add a single policy called the SSM automation role. We'll select next again, next review, and then in here, we're going to be specifying a role name, And then optionally, you can modify the role description, but I'll just leave it as the default and hit create role. So this role that we just created is going to be used as part of our change request that the system will then assume during the change request process in order to actually perform the actions that we define later on. In the case of an AWS organization, this process will be slightly different in that we want to use AWS Quick Setup instead. But for now, we're just going to create the role specifically, and then we'll specify it later on. So we're going to go back to the Systems Manager console now. And we're going to go to Change Manager. So within Change Manager, we're going to go to the Settings tab. So in the Settings tab, we're going to go ahead and hit Edit. We'll want to ensure that AWS Identity and Access Management is selected so that we can then specify that approval user we just created. In our template reviewer section, we will go ahead and hit create a SNS topic. And then in here, we'll specify SSM workshop SNS and hit add notification. Then go down to our template reviewers and add our approval user that we just created. And then for the change freeze, we'll also specify our approval user. And then in the best practices section, we're going to ensure that we specify that template reviews and approvals are taken place before they are actually used. Like I mentioned during the PowerPoint presentation, you can also choose to include that monitors using CloudWatch alarms are included for all templates, as well as enabling the change calendar integration so that Change Manager first checks if the calendar is in an open state. But for the purpose of this workshop, we'll leave both of these disabled for now, and we'll just go ahead and hit save. So now that we configure Change Manager, we'll next create a change template. In here, we're going to be specifying our template name. So in this case, the example that we're going to be working with is just restarting our EC2 instances as part of a change request. So I'm going to fill out restart instance template. In here, you can specify a description optionally, and then choosing the template type. So we'll be selecting standard template, but again, you can always specify emergency change template, which would then bypass any active change calendar restrictions. So in our runbook options, we're going to select the drop-down list, and we'll search for AWS Restart EC2 instance and select it. Alternatively, you can always define multiple runbooks that could be used, or you could specify any runbook can be used as part of the template. Down here, we can then see our template information. So what type of details should be included as part of your change request. This does have Markdown support, so you can always use Markdown formatting. But for now, we'll just leave this as the default and go on to the approvers section. So in here, we're going to specify request specified approver. And then we'll also select the SNS topic that we created previously and hit add notification. So in here, this is where if we wanted to add an additional level of approvers, we can optionally choose to include those. But for now, since we only have one approval user, we'll skip over that as well as the monitoring section and go down to the notifications where we'll select our same SNS topic, hit add notification, and then we'll just go ahead and hit save and preview. So the template was now created, and we can then submit it for review. So we'll see that it starts in a not reviewed status. So we'll go ahead and hit submit for review. So now our template is pending review, again, meaning based off the settings that we provided, the template must be reviewed before we can use it as part of a change request. So what we are going to do is log into the management console using our approval user. You'll want to go to the Iem console, and under the Iem dashboard, you can see the sign-in URL for Iem users. You can copy this. In your case, you'll most likely see an account ID instead. So what you'll want to do is open up a new incognito browser tab where we can then sign in as that approval user. And then we can go back to Systems Manager and Change Manager. And then we can go to the template section and see that template that we just created. So again, now we're signed into the console as that approval user, where we could review the submitted change template, see if there has been specific changes to the version of it. Once the template is actually approved and used, we could then always go to the change request to see any corresponding changes that have been initiated from it. And then we could also just review the overall task based off of the runbooks that we specified. So for now, we'll just go ahead and hit approve. Optionally, you can choose to include any specific comments, but for now, we'll just approve it. And then we're going to minimize this tab and go back to our management console. And now we can see that our template has been approved. So now we're ready to create a change request from it. So we'll select change or create request. We'll select our template that we created, and then we're going to fill out the details of our change request itself. So again, the template that we're using is the one we created, which will then call AWS Restart EC2 instance. So our change request, we'll just call it Restart EC2 instances. You can optionally fill out our change request information that was specified earlier, and then we'll go ahead to the workflow start time. So like I mentioned in the PowerPoint portion, we can optionally choose to specify this operation should take place at a later point in time, where we'd be defining a start and end time for it, as well as we could view a change calendar if we had created one. But for now, we're just going to say to run the operation as soon as the approvals have been met. In our change request approvals, we'll then select add and select our approval user. And our SNS notifications are already configured as part of the template itself. So we'll just go ahead and hit next. In our automation assume role, we'll select that change manager automation role that we created previously. And then for the deployment location, we'll select just for this account. But like I mentioned before, Change Manager has integrations with AWS organizations. So if we had an account that was part of an overall organization, we could then specify other accounts in other regions. For our deployment targets, we're going to select multiple resources. We'll select instance ID, and then we're going to choose a resource group to target those test Amazon Linux 2 instances. Optionally, you can leave the rate control options just as the default. Since we are just working on some test instances, we're going to specify a concurrency of 4, as well as an error threshold as 4, and select next. So now on this page, we can then review what is our proposed change request. If we need to go back and make any modifications to it, we can always hit edit. But otherwise, we'll just go ahead and hit submit for approval. And before we do that, we can see what are the actual next steps as part of the overall change request process. So step 1 is creating the request. Step 2 is waiting for those approvals to be met. And then if it is approved, step 3 is actually implementing the change. So now that our change request has been submitted, we're again going to flip back over to signing into the console using our approval user. To get that login again, I'm going to go to the Iem console and copy this value. So in here, we'll specify the login. And we'll go back to Change Manager. And then in here, we can see in the Request tab, our pending approvals. As part of this change request, we can see who submitted it, what are the runbook options, what is the current status of it. If we filled out our template information, we would also see those details if there were CloudWatch alarms associated. If we can see that's currently waiting for us to approve or deny it. So when you choose to approve or deny the change request, you can then add additional comments. So for example, if we were to reject this based off of some of the parameters that were being specified, we could include that information in the comments, noting that if the request parameters were changed, we would then approve it, so go submit a new change request. So for now, we'll just go ahead and hit approve, and that's going to begin the operation. So we're going to see that the status is now scheduled because the values that we specified earlier was to start it immediately upon approvals being met. So this will start shortly. And while we're waiting for that to start, we're going to flip back into our management console using our other account. All right, so now we're back in the Change Manager console with our original user, where we can see now that the change request has been approved. The status is now in progress. So if we go to the Timeline tab, we can see that that automation operation for restarting our EC2 instances have been initiated. If we go over to the automation console, so we can see that our restart EC2 instance is now in progress. So if we open it up, we can see that each of our instances are then performing the reboot operation. So once each of these instances finish performing their reboot, the status will then change to success. And we can go back to Change Manager and see the results for our change requests. All right, so now that we are complete with the workshop, we'll go down to the bottom of the page and we're going to go to the teardown instructions to clean up the resources that were created as part of this episode. So first, we need to delete some objects in S3. Then we're going to create that CloudFormation stack. We'll delete that corresponding SNS topic and the Iem users and roles, as well as the state manager association that we created. So to get started, we're going to go to the S3 bucket console. In here, we're going to select our two S3 buckets and choose to empty them. So that'll clean up all of those command output logs. And in the case of this resource sync, it'll clean out all of that information that was populated by the resource data sync. So now that those two have been emptied, we're then going to go over to the CloudFormation console again. And we will delete our CloudFormation stack. And while this is in progress, we'll go ahead and continue with the remainder of these steps. So we're going to open up the SNS console. We'll go to topics and then select that SNS topic that we created and enter in delete me. Next, we're going to clean up those two Iem users and roles that we created manually. So in the Iem console, we're going to go over to users. We'll select our approver user. And then we're going to select yes, delete. And then the same thing for our role, for the change manager automation role. We'll select this here and hit delete. And then the last thing that we need to delete is that state manager association. So we're going to go back to the Systems Manager console. Go and we'll delete our association here. And that's it. Once the CloudFormation stack has finished deleting, then all of the resources should be reverted back to the previous state, and you should no longer have any of those resources that were created as part of this particular episode. So thanks again for attending. Again, my name is Eric Weber. I'm a Senior Specialist Solutions Architect here at AWS for Cloud Management Services. And thank you for attending the workshop series. Look forward to the next episode. If you do have any questions about the content that we covered today or questions about the workshop itself, of course, please feel free to paste them in the chat and we can answer them now.